are going to discuss about data abstraction. First, for what is data abstraction? For the system to be usable, it must retrieve data efficiently. The need for efficiency has led to designers to use complex data structures to represent data in database. Since many database systems users are not computer trained, developers hide the complexity from users through several levels of abstraction. There are three levels of abstraction. First, physical level; second, logical level; and third, view level. What is the physical level? The lowest level of abstraction describes how the data are actually stored. So, physical level is equivalent to how the data are actually stored. The physical level describes complex low-level data structures in detail. Logical level. The next higher level of abstraction describes what data are stored in the database and what relationships exist among those data. Database administrators who must decide what information to keep in database use the logical level of abstraction. The third one is view level. The highest level of abstraction describes only part of the entire database. The view level of abstraction exists to simplify user interactions with the system. The system may provide many views for the same database. Now we will discuss some DBMS technologies. First, data independence. Data independence is defined as a property of DBMS that helps you to change the database schema or the structure at one level of a database system without requiring to change the schema at the next or higher level. Data independence helps you to keep data separated from all programs that you use, instance or database state or snapshot. Databases changes over time as information is inserted and deleted. The collection of information stored in the database at a particular moment is called an instance of the database. Now what is schema? Schema is the overall design of the database is called the database schema or the structure or skeleton. Now let's study about what are the DBMS architectures. So there are three types of architectures. First, one tier; second, two tier; and third, three tier. With the one tier architecture, in one tier architecture, the database is directly available to the user. The user can directly sit on the DBMS and use it. That is, the client server and the database all present on the same machine. For example, to learn SQL, we set up SQL server and the database on the local system. Sometimes it may be referred as centralized system with single user system. Here is a flowchart of a centralized computer system where CPU, disk controller, print controller and tape drive controller are connected via memory controller and then memory. Let us study about two-tier architecture. The two-tier architecture is similar to a basic client-server model. The application at the client end directly communicates with the database at the server side. APIs like ODBC, GDBC are used for this interaction. The server side is responsible for providing query, processing, and transaction management functionalities. On the client side, the user interfaces and application programs are run. The application on the client side establishes a connection with the server side in order to communicate with the DBMS. An advantage of this type is that maintenance and understanding are easier, compatible with existing systems. However, this model gives poor performance when there are a large number of users. Now the three-tier architecture. In this time, there is another level between the client and server. The client does not directly communicate with the server. Instead, it interacts with an application server which further communicates with the database system, and then the query processing and transaction management takes place. This intermediate layer acts as a medium for the exchange of partially processed data between server and client. This type of architecture is used in the case of large web applications. Now, what are the advantages of three-tier architecture? First, enhanced scalability. Due to the distributed deployment of application servers, now individual connections need not be made between client and server. Data integrity. Data integrity is maintained since there is a middle layer between client and server. data corruption can be avoided or removed. Next one is security. It is improved. This type of model prevents direct interaction of the client with the server, thereby reducing access to unauthorized data. The next is server system architecture. Server systems can be broadly categorized as transaction servers and data servers. Transaction server system, also called query server system, provide an interface to which clients can send requests to perform an action, in response to which they execute the action and send back results to the client. Usually, client machines ship transactions to the server system where those transactions are executed, and results are shipped back to the clients that are in charge of displaying the data. Requests may be specified by using SQL or through a specialized application program interface. The server system is data server system, which allow clients to interact with the servers by making requests to read or update data in units such as files or pages. For example, file servers provide a file system interface where clients can create, update, read and delete files.